So imaginary numbers by themselves aren't overly difficult. You just have to remember what the different powers create for it. Okay, but when they create binomials with these, you create what's called a complex number. Okay, that's where it gets a little bit more difficult because you have a real number portion and an imaginary number portion. Okay, they got both of them. Okay, so to do the sum, to add and subtract complex numbers, we add the real parts together. So add all the real numbers together and then add the imaginary parts together. So if you remember the last lesson, I said when we're adding and subtracting complex or imaginary numbers, you kind of treat the I as like a variable. Okay, so like 5x minus 2x is 3x, so 5i minus 2i is 3i. Right? When you're finding the product of these, you just FOIL them in the same way that we normally do. Just obviously remember that I squared equals -1. And for the quotient of these things, once again, the conjugate's going to come back. Right? So we're going to utilize that conjugate to cancel out middle terms, and we know I squared is going to be -1, so that's going to help us get our denominators rationalized. Okay, so let's jump right into the examples. So we'll start with a simple addition. Okay, we're just going to combine like terms. Okay, so those are all like terms, and these are like terms. Okay, so you just combine like terms. So 4 plus 3 is 7, minus 4 is 3. And -2i minus 3i is -5i, plus 7i is plus 2i total. So this would be the final answer. You combine like terms. Okay, this one's just a product, so we're just going to FOIL. Work this all out. We'll have 6 minus 4i plus 15i minus 10i squared. Now remember that I squared is -1, so we can actually combine these as like terms and combine these as like terms. Okay, because I squared is -1, so you can really forget about the I squared and change the sign. Okay, so 6 plus 10 is 16, and 15 minus 4 is plus 11. The final answer is 16 plus 11i. Okay, 3 is a little bit more difficult because we're going to distribute, but we have to worry about the square first. So this is, remember, 2i minus 1 times 2i minus 1. Do not just square both of those terms. You absolutely have to FOIL it out. So we have a 3i out front, and on the inside we're going to FOIL this. So we'll have 4i squared minus 2i minus 2i plus 1. Okay, let's combine like terms first. Remember I said when you have an I squared, just forget about it and change the sign. So we make that a -4. Now we combine our like terms. We've got 3i up front. We've got -4 plus 1 is -3. And then minus 2i is minus 4i. And now we can finish this problem up, okay, by distributing. So 3i times -3 is -9i. And 3i times -4i is going to be -12i squared. I squareds, cross them out, change the sign. So we've got 12 minus 9i. Final answer. More examples. Yay, we're just going to go back to easy ones. Let's subtract some stuff. Alright, combine the like terms. 3 minus 2 is 1. -2 plus 3, remember, minus -3, is plus I. 1 plus I. Final answer. Now we get to the crazy conjugate things. Okay, since we have this I in the denominator, we need to multiply both top and bottom by the conjugate of the denominator. So 4 plus 2i, or sorry, 2 plus 4i over 2 plus 4i. Okay, we have to FOIL the top and the bottom. So we FOIL the top. We're going to get 8 plus 16i minus 6i minus 12i squared. And on bottom, we'll have 2 times 2 is 4. Plus 8i minus 8i. Just want to show this for the first time so you see that the middle term is always going to cancel out when you multiply by the conjugate. Minus 16i squared. Oh, squared. I squared. Okay, so let's work these out. All right, on top, remember we have this I squared, so we forget about the I squared. It's -1, so change the sign. And we can combine like terms. We've got 8 plus 12 is 20. 16 minus 6 is plus 10i. Alright, and on bottom, we've got our 8 i's cancel out. This I squared can go away. Change the sign. And we're left with over 20. Okay, now we can do some reducing, extra reducing here. We could take a 10 out of everything. Okay, so we've got 10. Basically, this is going to become 1. This is going to become 2. This is going to become 2. Okay, so 2 plus I over 2. Final answer. Number 6. Back to distributing. Okay, so we're going to distribute this I in here. We've got 6I minus 9I squared. I squared becomes negative 1. Change the sign. Final answer, 9 plus 6I. Notice how I always put the real term first and the imaginary term second. Even though this is technically the same thing, right? We just write complex numbers with the real term first and the imaginary second. Just get in the habit. It's a good habit. Okay, number 7, all we got to do is FOIL. Okay, so, I need to press a marker. Good. Negative 6 for the front. The outside is positive 2I. The inside is negative 6I. And the last is plus 2I squared. Okay, the plus 2I squared can change to a negative 2, right? We get rid of the I squared and somehow symbolize to yourself that you know that's going to be a negative. Okay, so we can combine like terms, and we're going to have negative 6 minus 2 is negative 8 minus 4I. Final answer. Which, of course, if you'd like to factor these little guys, right, pull out stuff that's common, that's obviously fine, but this is the way that we're going to represent them for our final answers. All right, a couple more conjugate practices. Okay, remember this negative needs to go with either the top or the bottom. So what I'm going to do is I'm going to just throw it on the top because I think that's easier. Okay, I'm going to multiply both top and bottom by conjugate. So 2 minus I over 2 minus I. So on top we just have to distribute the negative 5, so we'll have negative 10 plus 5I. And on bottom we have 4. You know that the middle terms are canceling out, so don't even worry about it. Minus I squared. Okay, now I squared is just the same as 1. Right? Negative 1. So we just change that, and we'll be having negative 10 plus 5I all over 5. Okay, pull a 5 out of the top. Okay, rewrite this as 5 times negative 2 plus I. Then we can cancel out our 5's, and our final answer will be negative 2 plus I. Number 9 here. Getting back to more conjugates. Multiply top and bottom by 6 minus 2I over 6 minus 2I. We've got a FOIL, top and bottom, 12. Minus 4I plus 6I minus 2I squared. Get rid of the I squared, change the sign. On bottom, we've got 36 minus 4I squared. I squared goes away, change the sign. Combine some stuff, and we have 14 plus 2I all over 40. Okay, you can take a 2 out of everything and simplify, and we'll have 7 plus I over 20. That's our final answer. Now number 10 is just finding the reciprocal of 4 plus I. Okay, it's just one more final little reciprocal, or conjugate problem. Okay, so we need to find 1 over 4 plus I. Obviously, we don't want to keep it like that. We need to rationalize because we can't have that I in the denominator, so multiply by the conjugate. And we have 4 minus I over 16 minus I squared, which is the same as plus 1. Okay, so the final answer is 4 minus I over 17. That's it for imaginary numbers. Yay!